Okay, the second major use for the Pythagorean theorem is testing to see if a triangle is a right triangle. Now, I don't want you to confuse this with what we did earlier in the year where we were talking about, hey, let's try these sides. If the two sides add up to be greater than the third, then it can work and it's a triangle, what we call the triangle inequality theorem. This is specifically a test, that'll still apply, but this is specifically a test to see if it's a right triangle. All right? So the test for the right triangle is, I'll write this. Does the Pythagorean theorem work? Now, that's not the most mathematical way of saying it, but the reality is if you plug the values into a squared plus b squared equals c squared, all right, and the left side of the equation equals the right side of the equation, then you have yourself a right triangle. If they don't, you don't. It's that simple. So I have three questions here that I'm posing. Do the sides 6, 8, and 10 make a right triangle? So we'll plug it into a squared plus b squared equals c squared and see if they do. Now, the one thing you got to be careful of, make sure your largest number goes in for c. The other two are interchangeable. 6 squared plus 8 squared equals 10 squared. And really this is like a question, like does it, doesn't it? All right, so 6 squared 36, 8 squared 64, 10 squared 100. Is 36 plus 64 100? It is. So it is a right triangle. All right, let's try another one. Do the sides 4, 7, and 9 make a right triangle? Same concept. That's going to be my C. All right, so 4 squared plus 7 squared, does it equal 9 squared? 4 squared is 16, 7 squared is 49, 9 squared is 81. Well, 16 and 49 is what, 65? 65 does not equal 81, so this is not a right triangle. Now, I want to check real fast. Is it even a triangle at all? If I take the two small sides, add them up, 11. Is 11 greater than 9? It is. So it is a triangle, but it's just not a right triangle. All right, and finally, because I know you love radicals, 2, 5, and rad 29. All right, well, here you got to be a little careful. You got to make sure you know which is the biggest. It's not always the third one. You got to know which one the biggest is. So if that means you got to type the square root of 49 into a calculator, then, oh my God, that takes so much time. Of course it doesn't, so do it. But you'll see the square root of 29 is bigger than 5. So this is, once again, your C. So 2 squared plus 5 squared, does that equal radical 29 squared? Now, this is much easier than it looks. When you square a square root, all right, they're kind of like inverse operations. The squaring and the square root kind of sort of cancel each other out. All right, so you're going to be left with just a 29. All right, so you're going to have 4 plus 25 equals 29, which of course 4 plus 25 does equal 29. So check, and this once again is a right triangle. All right, so I hope this makes sense. Again, this was just an additional application of the Pythagorean theorem, and we're going to leave it alone from there. All right? Have yourselves a good day.